this video, we're talking about how to use the zero theorem to find the solutions to a quadratic equation. And in this particular example, we have the equation negative x plus x squared is equal to 6. Now, before we talk about what the zero theorem allows us to do, the first thing we know right away is that we need to reorganize this equation, because we should always write the terms of our equation in descending order of degree. So the highest degree variable should go first, which means this x squared term should come before this x to the first term, or just x. So we should put x squared first, x squared, and then our minus x. And then in order to use the zero theorem, the right-hand side of the equation is always going to need to be equal to 0. So in order to get the right-hand side to be equal to 0, we need to go ahead and subtract 6 from both sides of the equation, so that on the right here we get 6 minus 6 equals 0. So we'll just go ahead and put negative 6 over here, and that's equal to 0. The zero theorem is useful because it allows us to find the solutions to quadratic equations, which are different than linear equations because quadratic equations have a second degree variable involved. In other words, they have an x squared term involved, where linear equations just had an x to the first term involved. In other words, we've been used to solving equations like x minus 3 is equal to 6. We would just add 3 to both sides and we would get x is equal to 9, and x equals 9 would be a solution to this equation. This is a linear equation because the only variable involved is just this x to the first variable. But here we have an x squared variable, which means we're dealing with a quadratic equation. Obviously, finding the solutions to this equation is going to be more complicated than finding the solution to this linear equation here, and that's where the zero theorem comes in. The zero theorem tells us that when we have an equation p times q equals 0, when this is the case, then we know that either p equals 0 and or q is equal to 0. And that should make sense to us because if this is our equation here, p times q equals 0, or just pq equals 0, the only way this is going to be true is if p is 0, because then we would get 0q equals 0, or just 0 equals 0, and that would be a true equation. Or if q is equal to 0, because then we would get 0p is equal to 0, or just 0 equals 0, and that would also be true. Or if both of them were equal to 0, then we'd have 0 times 0 equals 0, and that would also be a true equation. But there's no way that this equation can be true if neither p is equal to 0 nor q is equal to 0. At least one of them must be 0, or both of them will be 0. So this is the zero theorem, and we can use it to find the solution to this equation. And the way that we do that is by factoring the left-hand side here. This is just a regular trinomial that we've already learned how to factor, and we're just going to factor it into two binomials that are multiplied together. And when we do that, we're going to get x, and then we have factors of 6 that are 3 and 2, so we can go ahead and say minus 3 and plus 2. And if we multiply this back out, we get x squared plus 2x minus 3x would be minus 1x, and then negative 3 and positive 2 gives us negative 6. So we factored this correctly, and now all we need to realize is that here we had p times q, but basically now all we've done by factoring is say that we have p times q equals 0, like this. So our equation, our quadratic equation, is now in the same form as the equation in the zero theorem, and all we need to say is that in order for this equation to be true, one or both of these factors must be equal to 0. So either x minus 3 must be equal to 0, and or x plus 2 must be equal to 0. And then we can solve each of these linear equations just like we solved this linear equation up here. We're back to something that's really simple for us to do. So this first one, we can just add 3 to both sides and we get x is equal to positive 3. Here we'll subtract 2 from both sides and get x is equal to negative 2. What this tells us is that 3 and negative 2 are the solutions to our quadratic equation, because if x is 3, then this first factor will be 0, and we'll get 0 times quantity x plus 2, or just 0 equals 0, and x equals negative 2 is another solution to the equation. So now what this tells us is that x equals 3 and x equals negative 2 are both solutions to the equation, and we can prove it to ourselves by plugging these back in. So if I say that x equals 3 is a solution to the equation, and I plug it back into my factored equation here, what I'm going to get is 3 minus 3 in this first factor here. Instead of x minus 3, 3 minus 3, and then 3 plus 2 equals 0. And when I simplify, I'll get 0 times 5 is equal to 0. Well, 0 times 5 is just 0, so I get 0 equals 0, and that checks out. The other solution is x equals negative 2, and if I plug that in, I'm going to get negative 2 minus 3, negative 2 plus 2 equals 0. And when I simplify, negative 2 minus 3 gives me negative 5. Negative 2 plus 2 gives me 0. And I know that negative 5 times 0 is 0. So I get 0 equals 0, and that checks out also. So I can say that x equals 3 and x equals negative 2 are solutions to the equation, and that's how you use the zero theorem to find solutions to a quadratic equation.